Okay, here's a look at mean value theorem. So mean value theorem, first thing we want to do is determine the slope on the interval and then check the derivative and see if the derivative ever equals the slope on the interval. So therefore f of negative 2 is equal to 2 and f of 2 is equal to 2/3. So my slope will be the change in y's, 2 minus 2/3 over the change in x, negative 2 minus 2, which is equal to negative 1/3. So I just did that math out real quick. Using the quotient rule, f prime of x is equal to x plus 1 minus x over x plus 1 quantity squared. So we get f prime of x is equal to 1 over x plus 1 squared. So the mean value theorem says take the slope of the secant, set it equal to the derivative, and there should be an x value in between negative 2 and 2 that is equal to, that has that slope. So x plus 1 quantity squared is equal to negative 1/3. The easiest way to handle this one is to square root both sides, but since I can't take the square root of a negative, we have a problem. So let's take a look at the graph, and here's our problem. At negative 1, it looks like we have a vertical asymptote. So since the function is not continuous, nor is it differentiable at negative 1, the mean value theorem cannot be applied on this interval. Even though if I do connect these 2 points, I do get a slope of negative 1/3. This is just the computer programming using rounding to the 10th value. It's negative 0.3 repeating because we already calculated that to be negative 1/3. So even though that the slope of this secant is equal to negative 1/3, I find it pretty hard to believe that there's even going to be a tangent line that's in between on this function or this piece here that's going to have a slope of negative 1/3. It's going to have the same slope of this secant right here. But regardless, mean value theorem says, the first thing says that the function must be continuous and differentiable on the interval. Well, since there's a vertical asymptote at negative 1, you have negative 1 in the denominator, mean value theorem can't be applied. So therefore, since it's not continuous at negative 1, also not differentiable at negative 1. How do we know that? Well, if you set the denominator equal to 0, you get negative 1, so therefore negative 1 is in between negative 2 and 2, so therefore it's not continuous. There's a vertical asymptote there. And it's also not differentiable when you set the derivative equal to 0, or the denominator equal to 0. In this case, you get negative 1 also. So it's not differentiable nor continuous at negative 1, which is implied. If it's not continuous, it can't be differentiable. Therefore, you cannot apply the mean value theorem on this interval. So we want to write out just something real quick like that, just stating that it can't be done. So let me write that. So since f of 1 doesn't exist, nor does f prime of 1, the mean value theorem cannot be applied to f of x on the interval negative 2 to 2.